Hey, it's Mr. And going over your Math 5 quiz number 1, volume 1, module 1, topic 1, topic 2, taken September 6, 2019. This is version G. Write my name. Directions show all your work in the space provided and box your answers. Multiple choice number 1. Which equation is equivalent to 4 times 2 minus 5x equals 6 minus 3 times 1 minus 3x. Okay, you'll notice that they don't have an answer, like x equals. So they kind of want us to just work on both sides until we get something that works like this. Okay? So the first thing I'm going to show you guys is the order of operations. Order of operations. As a quick review, you always go left to right in the order of these chunks. So when you're in this first chunk, then you go left to right. This chunk, left to right. And the reason why we use the order of operations is to simplify something. Simplify one side of the equation. Or if I had an expression, you're just simplifying this. Okay. The left side, it is okay. Well, first thing, let's just go through parentheses and exponents. There are no little numbers. And then in the parentheses, you cannot combine like terms there. 2 minus 5x are not like terms because this one has no x and this one does have an x. Okay? So I can't do anything inside the parentheses and there's no exponents. Check, we're done. Now I'm going to do multiplication as I go left to right. So over here, you can distribute the 4. So this would be 4 times 2, which is 8. And then 4 times negative 5x is negative 20x. On this side, the temptation is for you to do 6 minus 3. And the reason why you can't do that is because addition and subtraction is last. We have to do multiplication and division first, which tells us that this negative 3 needs to be distributed. So I'm going to have 6, and then negative 3 times 1 is negative 3. Negative 3 times negative 3x is positive 9x. So I have 8 minus 20x equals... Then here now I can combine like terms and get 6 minus 3 is 3 plus 9x. Okay, notice that all the x's are on one side. So it doesn't matter which side you put them on. You always want to move the smaller number. So I'm going to add 20x over in this direction. This will cancel and this will give me 29x. And at the same time, I'm going to move, since I have the x's on this side, I'll move the constant to this side. So that is subtracting 3. This will equal 0, and we're left with a 5 there. So 29x equals 5, and that is choice C. Is your answer. So thinking about equivalent expressions, you're going to have to do some simplifying. Question number 2. Terrence asks his employees to determine the number of new tiles added to design 2 to create design number 3. Each employee describes a unique method to determine the number of additional tiles needed to create design 3. So essentially going from design 2 to design 3. Represent each of the employees' explanations with an algebraic expression that describes how many new tiles must be added to an n by n square to build the design. We did this exact problem in class, so it should not be a surprise. This person says... I must add 3 tiles to each of the 4 sides of the white squares, which is 4 times 3 tiles. Then I must add 1 tile at each corner. So the number of additional tiles added to the design 2 square floor design is 4 times 3 plus 4. So the question is, what expression can you get from this? Well, they don't tell us in this problem, when we were talking in class, how you assign variables for expressions to represent something. So our variable here is n. N represents the design number. So n is equal to 3 because we're trying to get design number 3. If I put n everywhere around here on my picture, or the expression this person wrote, I have something that looks like this. 4 times 4 n plus 4s. 4 times n plus 4. And you can kind of see that because you have no parentheses. because there's no parentheses here. So that would just be 4n plus 4. Because there's 4 n's. Let me count. 1, 2, 3, 4. Those are my 4 n's. And then this is really 4 1's. 1, 2, 3, 4. So 4n plus 4 is our answer. Pull my page here. For questions 3 to 8, identify and circle as linear, quadratic, exponential, or neither. Smooth curve increases quickly. That would be exponential. Table of values here. I'm going to make sure the left side is counting by 1. Super important. Plus 1, plus 1. And then on this side, I got to figure out if they are adding or multiplying. So here, this would be a plus 4, plus 6, plus 8. We don't have a first common difference. If this was the same number, that would be a first common difference. That would be linear. We don't have the same number there, so I'm going to keep going. Add 2, and then add 2. So I have a second common difference. Therefore, the answer is quadratic. Question number 5. I'm looking at my equation here, and then I realize the base is a number, and my variable, the exponent is a variable. My answer is exponential. Remember, this is in the form of a, b, x, or y, g of n equals g1, the first number in the list, times the ratio to the n minus 1 power, which is a geometric explosive formula. Let's look at question number 6. So this looks kind of confusing, so what I like to do is I'd like to take the table of values and just kind of change it. So it's -2, -1, 0, 1, and then 2. And then -1, 1, 3, 5. Uh-oh, kind of made it crooked. 7. And then you can either graph this. That'd be a good idea. Let's just graph this. -2, -1, -1, 1, 0, 5, so something up here. No, 0, 3, see what happens, I can't read, not that one. And then this would be 1, 0, 3, 1, 5, something way up here, and then 2, 7. So I think it looks like a line there. You see it? Let's double check. So go from here to here, +2, +2, +2, +2. They're all the same number, so that would be linear. First common difference, and graphing it gives me linear. Question number 7. Although this would be linear and this would be linear, the fancy word is this is a piecewise function of two linears, and that this is called an absolute function. And really what it is y equals the absolute value of x. This is what the equation is. It's not linear, it's not quadratic, not exponential. The answer is neither. Question number 8, I have a polynomial, which just basically means you have x's and y's. And then I'm looking for the highest degree. The highest degree here is 2. 2 is quadratic. So let me count up the points on that side. So here you have 6 problems, 6 points each. So that would be a 6, 2, and a 2, and then 2 points for your name. 2, 4, 6, 12 points for the front side. Let's go to the back. All right, for the back side it says draw design 7. So I have this here. And if you color code it, if you think about this, 1 here represents 1 by 1. 2 represents a 2 by 2. Design 3 represents a 3 by 3. So design 7 is going to have 7 boxes. Now, I meant to have given you graph paper here, and it didn't turn out well, so I will do better next time. 2, 3, 4, 5, 6, 7. If you can't see, it's okay. I'm just going to literally count 1, 2, 3, 4, 5, 6, 7. If I had a ruler, I'd measure it. So 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Messed up, but as long as yours can get the idea in there, it's good. So, question: how many shaded squares are there in design 7? So one way is you just think about it. This is 7 by 7, so 7 times 7, and then you have these two boxes, so plus 2, so that'll be 49 plus 2 gives me 51 is my answer. And then, remember, no shaded, sorry, I told you guys to cross that off. So it's to complete our table. So how do you complete this table here? You can count. So 1, 2, 3. This would be 4 plus 2 is 6. Design 3 has 9 plus 2 is 11. And design 4, which we don't have. Okay, so I'm hoping what you see is, if I drew these red boxes, whatever these red box, whatever your design number is, you're always adding just 2. And then how do you get these boxes? Well, we just said design number, so this will be a 1 times 1, 2 times 2, 3 times 3. So that equals 1 times 1, 2 times 2, 3 times 3, 4 times 4 plus 2. We did 7 times 7 plus 2. So this would be 16 plus 2 gives me 18. So 18 would be your answer there. Circle 1, linear, quadratic, or exponential. Remember, you can either graph these order pairs, so let me box the answers, or you can just find your first common ratio or adding. So plus 3, plus 5, plus 7. So not linear, and then plus 2, and then plus 2. So that would be quadratic. Why? Because of a second common difference. Write an algebraic expression to represent the total number of squares in design n. So an algebraic expression has variables. You could choose x or n. It kind of tells us n, so let's just try to use that. Now, if you figure this out, if let's just say I put a design number n here, this would be n times n plus 2, which is n times n is n squared plus 2 is my answer. N squared plus 2 is my answer. Now, that was if you recognize the pattern. Let me show you guys a longer way, but it is a true method. It'll work. To find your a value, you take your common difference, so in this case our second common difference, and divide it by 2. So our common difference is 2, and then 2 divided by 2 is 1. So a is equal to 1. To find my c value, I'm going to have to work backwards. So to get that, I'm just going to go 4, 3, 2, 1, 0. And if you think about it, we need to get this right here is going to be, if you follow the pattern, 7, 5, 3, and this will be a plus 1. Because then our second common difference would be a plus 2 here, from 1 to 3. So some number plus 1 equals 3. Well, that number is going to be 2. And the reason why b equals 2, let's write that, b equals 2, is the 2 here represents those red boxes. It doesn't matter which design number is, you're always going to have to add the 2. That's why you're always starting off with 2. Right? Because if you had to draw design 0, which we kind of do, there is no middle, and it's just those 2 dots. 2 dots blocks. design number 0. Okay, so we got our A value and our B value. Now we need a C value. Excuse me, that is your C value, not your B value. And I reminded myself of that because you're using standard form. Y equals ax squared plus bx plus c. And the A value we got was already 1. The C value we know is 2. We're trying to figure out the B value, and now I have to think about where the x's and y's go. If you put your finger at your x's and y's, your tables, you'll get the x's and y's here. This column here represents the x, and this one represents the y's. So you get to pick an order pair. I would pick the one that has the smallest number, so I have 1, 3. Design number 1 has a total of 3 squares, so 1, 3. X is 1, y is 3. X is 1, y is 3. And then we just basically solve here for b. So 3 equals 1 squared is 1, and 1 times 1 is 1. B times 1 is just b. 1 plus 2 is 3. And if I subtract 3 from both sides, I'll get 0 equals b. So let's all put this together now. I have this formula or standard form of quadratics. So I'm going to put it now just your a, b's, and c's. So a is 1, b is 0, and my c value was 2. And then if I write this without 1s and 0s, this would be x squared. 0 times anything is 0. Don't have to write it. And then plus 2. And you'll notice that this equation here matches the one we got. Okay. Use your algebraic expression to determine the total number of squares in design 52. So you can use either of these. If you want to be super fancy, you can use function notation. So like something like this. F of x equals, or f of n, for n equal design number, n squared plus 2. And then the design number we want is 52. So every n value we're going to put in 52. And then if you take your calculator and put in 52 squared plus 2, that gives you 2,706. All right, so I wanted to go back up here, and we said that design number, the 52nd design, n value is 52. So every n value is 52, and then you add it to 2, so 52 squared plus 2 is 2,706 is your answer. And a good visual for that is, you have a design number with edges 52 times 52. I'm not going to draw out the little lines. And then you have those 2 red boxes. So then that's a visual of how we got 2,706. Question number 10. To determine whether the two expressions are equivalent, explain your reasoning. So where you see the word and, that's the two problems, number 1 and number 2. And I put an equal sign with the question mark because I want to know if they are equivalent or not. And then what I did here is I distributed the m, so I get 100m negative m squared plus 25. On this side, I wanted to match the order. So what I did first is I have a 100m, so I put it first. Then I have a negative m squared, so I put that second, and then I left the 25. Now this side matches this side, so check mark yes. Yes is determining yes or no. Determine they are, yes, they are equivalent because the expressions are the same. Determine whether the two expressions are equivalent. So you're showing me the math and then the yes or no, and then explain your reasoning. Remember, my explain word in math is really easy, just use because. All right, last problem. Archie is playing an online game with friends. Each round of the game, he earns 4 times his current total points. Total. So the first thing I'm going to do is make sure this is adding to ones. Adding ones. Okay, if you're ever skipping, just add numbers in front, or in between them. Over here, I have to figure out how do I get that. Well, it said he earns 4 times. So it looks like multiplication, and that is true. Times 4 times 4. So because you're multiplying a common ratio, that would be exponential. It is exponential. Explain, because there's my explain word, of a common ratio. Okay, so you can use either formula. I'm going to write both. G of n, form geometric, g1, which is your first number on the list, times the ratio to the n minus 1. Or y equals abx. A represents the first number in the list, so that would be 1 point. And then the b value represents the ratio, which is times 4 to the x power. And then you can just simplify that because you don't have to write a 1. So you have y equals 4 to the x power as your answer. So let's double check. These are my x values, and these are my y values. Think about an order pair, they're alphabetical. So x is 1. So if I put 1 here, 4 to the first power is just, that would be wrong. Let's take a look. Do you see how that works? So if I put in 4 to the second power, that would give me, second power would be 16. So this is off. So let's figure out the g1 value. The g1 value in the list has to be a 0. So this would be a plus 1. So I needed some kind of number multiplied by 4 is going to equal 1. So I'm going to put a box here. So let's try that. Math problem. Box times 4, so box times 4 has to equal 1, right? Because 1 times 4 equals 4. 4 times 4 equals 16. So if I divide by 4 here, I get the box to be 1/4. So that means that the first number on the list should have been 1/4. A is 1/4. How do we write that? 1/4 here. So then I would write 1/4 right there. So my equation is 1/4 times 4 to the x power. Let's see if that works now. Let's try 2. 4 to the second power is 16. And 16 times 1 is 16. 16 divided by 4 is 4. Let's try 3. 4 to the third power is 4 times 4 times 4, which is 16 times 4, which is 64. And 64 times 1 divided by 4, or 16 divided by 4, gives me 16. So this would work. Y equals 1/4 times 4 to the x power. That one works. All right, let's count for points. 2, 1, 2, 5, 6, 7, 9, 11, 15, and then 19. So 19 points on that side, and then 12, so that would give you 31. I didn't write that box up there, but you will lose points for not boxing or messy. And then remember, you might not see any scores on your multiple choice. It's because we're putting it into the Google form, and we'll just write total correct points here. So those should add up. Hope those corrections were helpful for you.
Math.
Say it again.